Hello. In today's world of unpredictable inference costs and evolving AI regulations, remaining flexible and future-proof is essential for any AI-enabled enterprise. In this video, we'll demonstrate how a simple, cost-based prompt router ensures a seamless experience for Dial users, both through our chat UI and programmatically via API access and Claude Code. Let's start with the chat UI. I'll send a quick request to my thinking model with budget router. Asking a simple question like, "Hi, what can you help with?" reveals in the debug logs that the request was routed to Opus 4.8. You can also see that this interaction has pushed us past our $100 budget threshold, which I'll show you in the backend in just a moment. Now, when I continue the conversation and ask for help deploying Claude Code, you'll see the router seamlessly switch and send my next request to GLM 5.2. Let's see how this logic is configured on the admin side, and then we'll set up an API key to call it from Claude Code. Over in the admin panel, you can see three models here. The thinking model with budget router that we just used, alongside the underlying Opus 4.8 and GLM 5.2. Looking at the configuration for our budget router, you'll notice this alias model's completion endpoint points to an application, rather than directly to either of the underlying models. This leverages Dial's Code Apps primitive, allowing admins and developers to deploy custom applications using Dial's Python SDK directly within the ecosystem. Let's take a look at the code. The logic here is incredibly straightforward. We've defined a budget for each model, such as our $100 limit for Opus. Once that budget is exceeded, the router automatically switches to the next model in our list of deployments. Dial's Code Apps and unified API make deploying a custom router like this simple. Next, let me show you how this routing works programmatically over the API. I've created an API key and assigned it to the default role, which is authorized to access our model router. Opening up PyCharm, which is pointed to my Dial repository, I'll use the terminal to run a few quick commands. This configures the environment for Claude Code to work through Dial by setting the endpoint URL, the API key, and some available models. Now, I'll launch Claude Code and select our routing alias. I'll ask it to evaluate my README. As you can see, it actively analyzes the codebase in README, making smart, relevant suggestions, all powered by the Dial router. We can verify this in the analytics logs, which show the initial call going through my API key to the router, followed by the subsequent calls to the underlying model. Today, we demonstrated a basic, budget-based model failover. But in production, you can easily build advanced logic to route prompts based on estimated token costs, volume commits, task complexity, or any other criteria that you need. In our next video, we'll dive deeper into using Claude Code with Dial and explore Dial's evaluation framework, which ensures your critical business logic continues to perform flawlessly even when the underlying models change. Thank you.